We are fine,
Great.
thank you. And you?
Please, your side.
By God's grace, I'm also good. Um, well, okay. So, how we gonna start the class?
Yes, please.
Okay. So let's just a recap on what we did last week. Last week, I remember we learned something on sampling, some definition of terms like population, sampling, variables, quantitative variables, qualitative variables, um, dependent variables, independent variables. And then we mentioned that for quantitative variables, you can also classify them into into two, which is discrete and continuous. And then we said that for discrete variables, mainly by counting, and then discrete variables are mainly by counting, like the number of students, number of midwives, number of children here and there, anything that is countable. And then the continuous, we said that it's mainly by measurement, something like temperature, weight, so on and so forth. And then I think we also mentioned what we call elementary units. And we said that the elementary units are the individuals in the population, whilst population is the complete set of entities. I think so far that's what you've learned, right?
Yes.
Yes, sir.
Yes, please.
Okay.
Yes, please.
So now that we know these techniques, now we learned last week that based on the sample, we are able to generalize for the whole population, right? Based on the sample, we are able to generalize for the whole population. So that tells you the need of a sample. That tells you the need of a sample. Okay, so it means that you have to get your sample, and then we said that the sample should be a true reflection of the population. The sample must be a true reflection of the population, meaning that the sample must be large enough to represent the population. And I think we even cited some example with the egg where I mentioned that um, if you fry an egg and then you take almost half or half of the egg, it is likely to get the salt content than someone just taking a small portion of it. You get it? So that tells you the need for the sample to be large enough to represent the population. And so today we are going to learn the sampling techniques, the techniques or the methods that we can use to derive our sample, or what we can use to get our sample. Okay, so why this? Okay. So when we say sampling, sampling is different from sample. Please take note of it. Sampling is different from sample. Okay. So when we say sampling, is the processes that we use, or the process that we go through to get our sample. So the processes that we go through to get our sample is what we term as sampling. I've already talked about population and sample, so I'm skipping this. So there is a population, and we go through sampling. After going through the sampling, then we derive our sample. Okay, so sampling is the processes that we use to get our sample. The processes that we use to get our sample. So for the sampling techniques, we can group it into basically two. We have the probability sampling or random sampling. So we have what we call the probability sampling technique or the random sampling technique. Probability sampling technique or random sampling technique. So for the probability sampling technique, these are done based on randomness. These are done based on probability. So meaning that for the probability sampling technique, it doesn't happen by chance. For probability sampling techniques, it doesn't happen by chance. You can't say it is based on randomness. It is not done based on non-randomness. So it means that it happened by chance. When we say randomness, that means that it happened by chance. Nobody influences the happening of that event or outcome. And then when we say non-probability sample or non-random sample, the non-probability sampling or the non-random sampling, it is done based on non-randomness. That means that it is not done based on randomness. It doesn't happen by chance. That means that something or someone or anything influences the happening of that thing. And so if we are to select some individuals to be part of a sample, if you go by non-probability sample, then it means that there is some little or some biasness because something or anything may influence the selection of your sample. Okay. So if you look at the sketch, the one on the left-hand side is a representation of probability sampling techniques. It's a representation of probability sampling techniques. And the one on the right-hand side is the non-probability sampling techniques. And you can observe that for the probability sampling technique, it gives you a true distribution of the population. So those that you can see in violet, those that we've colored in violet, these are the individuals that's being selected. Okay, these are the individuals that are being selected. So those individuals, you can see that it reflects the population very well. But if we come to the non-probability sampling technique, you see that it is concentrated only on the vertical and horizontal ones, which becomes biased. Only on the vertical and horizontal ones, which makes it biased. Okay, and so that is the reason why in most of the health-related research, we recommend you using the probability sampling technique. But it doesn't necessarily mean that you cannot apply your non-probability sampling techniques. Okay. Please give me some few minutes. Okay, let me ask. I can see that I'm having two people in the waiting room, which I'll ask my assistant to sort that one out whilst I teach. Okay, give me some few minutes. Okay, so let's continue. Those in the waiting room, they'll be sorted out. Okay. Okay, so under probability sampling, so once I teach, you can raise up your hand if you have any questions. Okay. So for the probability sampling techniques, today we are going to talk about the simple random sampling, stratified sampling, systematic sampling, cluster sampling, and multi-stage sampling. These are the sampling techniques that we are going to talk about today. Simple random, stratified, systematic, cluster, and multi-stage sampling techniques. Okay. So let me pause here and take questions before I start the explanation for the simple random, stratified, so on and so forth. So if you have a question, please raise up your hand. Mabel, Dede, Mabel, let me permit you to unmute yourself. So Mabel, you can now unmute yourself.
Sir, good morning. Thank you very much. Sir, if you can please go through the probability sampling and the non-probability sampling for me. It's a bit confusing somewhere. So if you can please go through again for me to get the clarification, I'll be glad. Thank you.
So what I said was the probability sampling is based on randomness. And then the non-probability sampling, it is based on non-randomness. Okay, so that's the main difference. The probability is based on probability methods, and then the non-probability is also based on non-probability methods or non-random. And then the probability is based on randomness. The key difference here is the randomness. Any other questions? Okay, so I don't have any questions, so now let's continue. So when we say simple random sampling, so for simple random sampling, it is done when you have relatively small population size. Relatively, you have a small population size, you can apply the simple random sampling. The simple random sampling, every individual has equal chance to be part of the sample. Every individual has equal chance to be part of the sample. So for simple random sampling, you are going to go by what we call the lottery method. So for example, if I come to your class right now, I have about 480 students in my class. So if I'm to select some individuals to represent the class, and I decide that I'm going to use simple random sampling, then what I'll do is I will have to number them, assign numbers to these individuals. So probably the first person, number 1, then I go to number 2, number 3, number 4, so on and so forth. So I get to the last person, number 480. Okay. So if I do this, probably I number this thing on a sheet of paper. And that's the reason why I'm saying that we are using lottery method. So what I can do is I can randomly select. Don't forget that these are the numbers that I've assigned to these individuals. Okay. I've assigned these numbers to these individuals. And so I'm going to select out of these 480 students. So any number that I pick, let's assume that randomly, let's say I'm selecting 5 individuals. So randomly, I'm going to pick 5 papers. So randomly, let's say I put it in a bowl or on a table. You see that here, I don't have any knowledge about the number that I'm going to pick. So I can just pick it from a bowl or on a sheet or whatever, where it is. So let's assume that I pick this guy. So it means that the person with this number 3, is going to be part of the sample. So if I pick number 480, it's going to be part of the sample. If I pick number 300, it's going to be part of the sample, so on and so forth. And so that is what we call by the simple random sampling. Simple random sampling. And so there's a sketch in the next slide, which I can use to illustrate what I'm saying. So now this is the population. We have this as the population. And so from this population, we are going to select 5 individuals. So this one, you can go by simple random sampling, where you can assign numbers. So this is number 1, number 2, 3, 4, so on and so forth. So the last person will be 15. So with this one, what you can do is, once I have my numbers now, I can now randomly select, randomly. So let's assume randomly I selected this guy, number 1, number 5, number 7, number 11, and number 14. So now these are the individuals who are going to form the sample. And that's what we call by simple random sampling. Simple random sampling. Okay. So I can see some hand up. So please. Ilyasu Mariama, ask your question.
Please, can I say that this is the simple probability sampling?
Please, I can't hear you.
Simple random sampling.
Louder.
Saying that, can I say that the simple random sampling is the same as thought, like when football teams are coming to play a match, where they toss and then like each select a portion, then when they toss, and when your dice turn, then it means you have won. Can it be an example of simple random sampling?
I'm not getting your example. I hardly hear you. What I hear is a toss and a football match. Your example is not clear to me. Please, I can't hear you. Can you come again? Yes.
I'm trying to
You see, your line is very faint. I hardly hear you. Can you reposition yourself and then talk to us, please?
Please, she wanted to make a scenario about the simple random. She said, for instance, can we say that during football, the way they select for them to go and play, can it be example of simple random?
The way they select what?
No, what I'm trying to say here is that, let's say the football match, before they play, they select the polls are 2 and the teams 2 are 2, but then they don't just say this team go here, this team go here. They toss, and when you win, then you make your selection of the goalpost you want to use as a team.
Oh yeah.
And I'm asking if that could be an example of a simple random sampling.
Oh yeah, that can be simple random sampling. You see that both teams don't have any idea about who is going to win. It just happened by chance. And this one, let's assume. So this one per the description, there it means that they are confined with these two posts. So the posts now become the population. Do you get it? And now they are selecting one, just one, as a sample where they are going to start. Do you get it?
Yes, please.
But normally, once it is just two things, we don't normally refer to it as a simple run. But per the concept, I think it's not bad.
Okay. Thank you.
Okay, so Mabel, Uneli.
Sir, please, can I use our class as an example, like in a way whereby anybody at all can be called and can be picked without any formula?
How your class picking it? How?
Yeah, like this midwifery class, general midwifery class. If I want to take a simple sampling, anyone at all can be picked at any.
You don't just say.
Maybe,
How do you get this anyone at all? This anyone at all that you are saying. How do you get it?
we are all midwifery students.
Mm-hmm.
General midwifery students.
Mm-hmm.
So we want to take a sample. So we are using the simple random sampling. In this category, I can just call maybe Helen, Dorothy randomly without saying that I want maybe those that are fair or I want those that are short. Can it be?
So with calling Helen, Dorothy, okay, that one, if calling them is different. When you are
Okay.
calling them, that one somehow someone may say it's biased because calling them by their name, probably you know their name. That's why you mentioned them. So that's why I said that you go by a lottery method.
Okay.
So the lottery method, you just assign numbers. So you don't know the name of the person that you are going to pick.
So you just pick it,
Yeah, you just pick it randomly. And so if fortunately for you pick Mabel, fine. If you don't pick her, so and so. Because we mentioned names, that one is a bias.
Okay. Thank you.
Okay. So please, if these things are comments, can we move on? If it's questions, then I'll permit you to talk. If it's comments, please let's move on. We have to finish what's expected of us today.
Hello,
okay, Agnes.
Hello, sir. Good morning.
Morning.
Sir, please, you made mention that with a simple random, it is used for a smaller population. So I want to know the total number or the population size that this method can be used on. Is there a number?
No, that's why I said it's relatively small population, relatively. So it depends. Something small may not be small for me. If I give you 10,000 CDs, probably it may not be small. But for me, it may be small. Do you get it? So that's why I said relatively. So it depends. If you think that you can apply it for this group of people, it's fine. But when it is large and you are trying to use it, it becomes cumbersome. Imagine if I want to select from, let's say, Garden City University midwifery students. You see, it will be very difficult for me to assign these numbers to all the midwifery students in Garden City University. But it doesn't mean it's impossible, but it will be difficult. So if you think you can apply the simple random, it's people will start questioning you. I hope you are getting it. But what if I want to do it just specifically to your class? That one would be much easier. So that one, there wouldn't be much question raised about your sampling method. Do you get it? So it depends on the scenario that you find yourself.
Okay. Thank you very much.
You're welcome. Okay, so the next person. Please, if you are done, you lower your hand so that I can call the next person. Sarah Boachi.
Yeah. Hello, sir. Please, good morning.
Morning.
Okay. So please, with the say simple random sampling, does it mean that the population or the group of let me say members are every member have equal chance of being selected, like randomly you can be selected. Please, is that what you
Exactly.
mean? Because I just
Exactly. Equal. They have equal chance. Because if I'm
okay,
selecting from
yeah,
your class, the possibility of selecting you is one out of the lot. So it's going to be one
okay,
out of the total number. Let's pressing one out of
okay, okay. Please, thank you.
Okay, so let's continue. Let's continue. Okay, so let's move on to the next one. Okay, I have another hand. The last person here, Irene. Okay, Irene, your hand is down. So I think we can continue. Irene, I think we can continue, right?
Sir,
Okay,
please.
talk to us. Then we can
Good
continue.
morning, sir.
Good morning.
Yeah. Sir, please, per the scenario, I want to know whether the American lottery is also part of simple random sampling.
What?
American lottery that they do.
The American lottery.
Yes, please. Is it
Oh,
an example?
if basically they apply the lottery method, then we can say it is simple random.
Oh, okay.
You see, but I don't know the process that they go through to get you being selected.
Okay.
But the
Sir,
fact
that
that
one is large. It's
but
like
the
the
fact
whole
that
world.
so I don't know the processes that they
Yes,
go
the
through.
whole world.
But
That one too
if
is an example of lottery. If you won, then
yeah,
you
but
be
if they are
selected.
using the lottery method, there's something we
Yes.
call the lottery method. You see that when you are watching this television where they stick lotto and then they put these numbers in a
Okay.
machine, right? You
Okay.
see that they put it
Yes.
in a machine, and that is what we call the lottery method. So you see that randomly, someone will press a button and then a number pops up. Is that not
Okay.
it?
Yes,
You
please.
see that nobody can predefine the number coming out. And so
Okay.
that's what we call the lottery. And so that's why we are saying that if you assign the numbers and randomly I select, it's more or less like the machine selecting a number from the lot. And so that's why we say it is a lottery method. And
Oh,
so
okay.
for the American lottery, I don't know how they do those things. So I can't stick my neck out and tell you that is a simple random sum.
All
But
right,
if
sir.
it is
Thank
based
you.
on this lottery thing, then we can say it.
Okay. Thank you, sir.
You're welcome. Okay. So now let's move on. Another thing is what we call the Jafar. Please let me finish with this, then you can ask your question. If it's a question, let me finish with what I'm going to explain, then you can ask your question. So another one is what we call the stratified sample. The stratified sample. The stratified sample. For the stratified sample, it's used for a population where you have different characteristics in there. There's a lot of variation in there. That means that in the population, you are having a lot of variations, different characteristics in there. And so what you do is you have to group them into common groups. So in the common groups, they'll be having common characteristics, but between the groups, they'll be having different characteristics. So now let's assume that I want to select some midwives to represent Garden City University. So then I will say that these midwives, I have some coming from WA, some coming from Keita, Kufodia, so on and so forth. Okay, then it is very likely that they will be exhibiting different ethnic characteristics. Okay, so if that is the case, I'm going to use stratified sample because if I'm not careful, if I go by simple random sample, it is possible I can select only those from WA. And so if I select only those from WA, it will not be a true reflection of these midwives. So the best thing is to go by simple random sampling. Oh, sorry, stratified sampling. The best is to go by stratified. So you group all the WA in one, all the Keita in one, Koforidua one, so on and so forth. So when you have this, then you can go within each group and do your selection. Okay. Then you can go within each group and do your selection. And if you do that, you see that that will be a true reflection of this midwife than selecting using a simple random, which you may end up selecting only the WA students. So this is a sketch. So let's assume that these are the midwives. And now we are using all those in red. Let's say they are from WA, all those in blue, Kumasi, and all those in yellow are from, let's say, Keita. So now we are going to select based on these groupings. And each group is what we refer to as stratum. Do you get it? Each group is what we refer to as stratum. So we are now going to select within each group. And then based on that, you can get our sample. And you see that that will be a true reflection than using the simple random sampling. So when you are using stratified sampling, you can use it for a population where it is perceived that you have different characteristics. Okay. So that is what we mean by the simple. Oh, why do I keep saying simple? The stratified sampling.
We can't see your slides.
Either you can see or you can't see yours.
It's there. Swipe to left of your screen. You
So
will
say
see.
you can see. Don't say you can see. Okay. So that is what we mean by the stratified sample. So let me pause, take questions, then I move on.
So please explain the stratified sampling.
Please, I'll call you. I'll call you. If you have a question, raise up your hand, then I call you. Please. Okay. Jifa, please ask your question.
Okay, sir. Sir, good morning.
Good morning.
Hello, sir.
Good morning.
Hello.
Good morning, please.
Sir, please, I wanted to find out if... Okay. Sir, please, I wanted to find out... Good morning, sir. Good morning.
Please
Hello,
talk to
sir.
me. Please talk.
Please, I wanted to find out about the simple random sampling. In a case you have population, and you decided to number them maybe from 1 to 5, and then you now select maybe those who have the same number like 1, those who had 1 or 2 should be grouped at one side. That there are those that you are supposed to pick as your sampling size. Are they also classified as sampling sampling?
No. You can't do that. That's what you are doing. I don't know the sampling technique that you are doing, but that's not simple random sampling.
Okay. Okay. So master, with that one, which one will it be classified? Because what I'm saying is like, assuming you have a group of people in a row, and you want to group them, like make a sample, and you make them number themselves. These people will start 1, 2, 3, 4, up to 5, and then the other people, the next group will start 1 to 5. Then later you now group them. Those who have maybe the same number, let's say 1, they should come out. Maybe there are those that you want to take as your sample size. Or
All
13.
those who have one should do what?
So come out. Maybe they are those that you want to pick
And you get
as
there.
your simple random sampling.
No, that's not simple
Okay.
random sampling. That one is
Okay.
not simple random sampling. That one is more or less someone is more or less convenience sample. I don't believe that's a probability sample.
Okay.
I don't believe that's a probability sample. That's why I started by saying that I don't know the kind of sampling technique that you are using. But this is not simple random sampling.
Okay. Thank you. Thank you.
You know what you should know is for all these sampling techniques that we are doing right now, they are the random sampling techniques or probability sampling techniques. These ones, there's no way you should influence how you do your selection. Okay. Nothing should influence how you do the selection.
Okay.
Did you get it? Per your description, you've numbered them 1 to 5, 1 to 5, 1 to 5. Why is it that you are selecting all those 1? That means you are introducing some biasness.
Okay.
You get it? So you don't need to introduce any bias. That's why I'm saying that I think this may be convenient. I'm not certain about it, but keep in mind that in probability sample, you do not introduce any biasness. Okay?
Okay.
You do not introduce any
Okay.
biasness.
Okay.
The moment you introduce some biasness, then you are moving into the non-probability sampling technique, which that one, there's a lot of them. Okay. Okay. So let me take the next question. So please, if you are done, you can lower your hand. So the next person is Ilyasu Mariama. Hey, Mariama, you've been talking today. You let your
Say,
colleague talk. Okay, Mariama, talk.
please, with the stratified sampling, can I say that as you use the example, midwives from different regions, while and Tamale and other centers will be grouped in different, those from Wa will be in one group, those from Tamale, so that when you are doing the selection, you will be having all the characteristics from the various centers. So with that, those groups, the way you are going to get the people from Wa to join the sample, is it going to be a simple random sampling that you would use to get those people from Wa Center, from Tamale Center? Then those people now come together to be the stratified sampling.
Okay, that's good. You have the idea. That's perfect. You see, when you group them into groups, when you are selecting from the groups, you don't just go and select, let's say, Mariama, because Mariama is a friend of mine in Tamale or wherever. So you are just going to select it. So after forming the groups, you then apply the simple random sampling in there. And so there's a statement like this that simple random sampling is the mother of all probability sampling techniques. You realize that at any point in time, among these sampling techniques, you'll be applying the simple random sampling. So the simple random sampling, that's why I'm saying that there's a statement that statisticians are saying that it is the mother of all sampling techniques. So after grouping them, you don't just say that I'm going to select the first guy here and the third guy here. You apply simple random sampling in the group. Then you can select.
Thank you.
Okay. Why do I keep saying? Okay, any other questions? Any other question? Then I continue.
Sir, please, some people are still in the waiting room.
It's up to them. You are supposed to name yourself correctly. So that shouldn't be a problem. Okay, there's someone to take care of it. So that's not my problem at all. If you do it correctly, if you name yourself, you will not be in the waiting room.
Okay.
Please, any other question before I continue? Okay, Theresa Asamoah, ask your question.
Sir, please, the classify sampling technique. My network was breaking, so I couldn't hear it. So I would like you to please explain instead that.
Okay. So what we say for the stratified sampling is when you have a population where they are having different characteristics, you have to group them into common characteristics. And then in the group that you form, which we call them structure, each one is referred to as structure. And in the group, you can now go inside and do your selection from the groups to form your sample. So that at the end of the day, you get a true reflection of the population.
Okay. Thank you.
Okay, so now let's move on to the next one. The next one is what we call cluster sampling. Cluster sampling. So in most cases, students confuse themselves with cluster and stratify. So for cluster sampling, you have to divide the group, the population into groups. But this time around, you will see that it is used for a wide geographical area, and in the group, you see that this one in the group, they will be having some similar characteristics. Okay, so it is used for a wide geographical area, and so you group them into subgroups, and in that subgroups, you can select a group to represent each, or you can then go by what we call single stage or two-stage cluster sampling. And so these clusters, the clusters that you form, it depends on you, the researcher. You, the researcher, have to form the clusters. Nobody will come and tell you that you this to form that, you this to form that. And these clusters are the groups. You see that the stratified sampling, we call the groups as strata or structum for each one, structum. But here, each group is called cluster. So for example, if I want to do a research in, let's say, Ghana, you see that Ghana is very large and it is perceived that we are all Ghanaians. So we have common characteristics. So now I'm going to group ourselves into groups. So how do I do it? Now I'm going to use the regions. The regions are now going to be my groupings. Okay, so Upper East will be one cluster, Upper West another cluster, Northern cluster, Ahafo, Ashanti, Volta, so on and so forth. So all these things are the clusters. And now that I form my clusters, there are two options for me. I can go by what we call the single stage cluster sample. The single stage cluster sample. So for the single stage cluster sample, let's assume that this is Upper East, Upper West, Ashanti, Volta, and Central region. So if I'm going by the single stage cluster sampling, I will randomly, that's by the simple random, I will randomly select a cluster. So if I choose cluster 1, which here we said it is what? Upper East. Okay, we said Upper East. So if I select a cluster, let's say cluster 1, which is Upper East, then it means that all the individuals in the Upper East, all the individuals in there are going to be part of the sample. Okay, all the individuals in there, they are going to be part of the sample. And also, if I select Volta region, all the individuals in Volta region are going to be part of the sample. If I select Central region, all the individuals in Central are going to be part of the sample. So that is what we mean by single stage cluster sampling. The single stage cluster sampling. So it means that the moment you select a cluster all the individuals in there are part of the sample. All the individuals in there, they are going to form part of the sample. And that's what we call by single stage cluster sample. On the other hand, if I have two-stage cluster sampling, two-stage, let's say this time around, you are going to use two-stage cluster sampling. So for the two-stage cluster sampling, that one, after doing the single stage, I hope you can see that this one is a single stage. After doing the single stage, you do not end there. You go in the cluster and then you do another selection. But don't forget that all these selections are based on what? Randomness. And that one you can apply the simple random. You do these things by randomness. So for the two-stage, you don't end at one stage. After you've done the one stage, you now come in the cluster. Once you've selected cluster one, you come in there, then you do another selection in the cluster to be part of the sample. I hope it's clear. Let me take questions on cluster sampling. So if you have any question on this, you can tell me. So if you have any question, please raise up your hand. Okay. Let me. Oh, please. Okay. Okay. So the name, please forgive me if I don't mention your name correctly. Okay. Is it Akai Shine Kekeli? I don't know if I mentioned it correctly.
Yes, please, it's correct.
Oh,
Kekeli, shine.
Oh, Kekeli. So your name is it sounds very nice.
You're
Are
not
you in
down.
Kita? Or Dan?
I'm in the Volta region.
Oh, good. I hope I come there and see Kekeli. Okay, so
Yes,
please,
sir.
that's just by the way. I'm ready for a question.
Okay, sir, please. So, with the two-stage cluster sampling, when you are going to when you group the regions, for the example you use, into Ashanti, Volta, and then probably maybe the first one with a single one, you select only Ashanti to represent the whole group of cluster, the whole different regions. You randomly select Ashanti for the single one. So you select one cluster. So all the individuals, they are representing the cluster
Ghana.
you've made.
They are representing Ghana.
Ghana. Now, when you come to the two-stage, will Ashanti still be included or it will be excluded so that the remaining clusters that are left down you choose two from?
Okay. So you don't say that all these things you just have to define your methods before you start any research. You get it? And so if you define your method that you are going by two-stage, then if you select Ashanti, right? If you select Ashanti, then you come into Ashanti and you do it. That means you are done with Ashanti. You get it? But you will do the single stage first. So randomly you select probably Ashanti, Volta, where you are, and then that of Central. Do you get it?
Yes,
Do you get the
please.
point? So then
Yes,
you can now come within each cluster and do your selection.
okay.
There's something that we call with replacement. Anyway, let's end. I don't want to get any. It's okay. Let's end here. That's fine. That's fine. Kekele, are you okay?
Yes, please, I'm okay.
Are you safe? If you are safe, okay, later. I don't want. Wow. My system. Can you guys still see my screen?
Yes,
Sir,
please.
we can see your
Yes,
there.
sir.
Yes, sir.
Yes, sir.
My internet went off.
Yes,
So
sir.
okay. Now let's move on to. So Kikilo, you can lower your hand. I'm done with you. Okay, the next person is Angelina Drew. Angie, talk to me.
Okay, thank you, sir. Hello?
Please, I'm ready. Talk to me.
Okay. Sir, based on the explanation that you just gave, I just wanted to use maybe
Angie, your
Ghana
line
as a whole.
dropped.
So the number of people.
Your
Hello?
line dropped. So can you start all over again?
Okay, so sir, please, I wanted to say that in case I'm using the number of tests, so that becomes a cluster sampling. And then now the single stage cluster becomes maybe I decided to divide them into regions.
Angie, do you know something? Can you reposition yourself, then come again? Because I hardly hear you. Your line keeps dropping and coming here.
Hello?
Please, you just reposition yourself, okay?
Okay,
And
sir,
then come
please,
again.
is it okay?
No, you just reposition yourself and let someone talk. Probably by
Okay,
then
okay.
it will be fine, okay? So Florence Bema, talk to us.
Okay, so please, good morning. I think I'm not getting the two-stage cluster sampling. From my understanding, so after you've selected your sample cluster sampling, then out of those cluster that you which has been sampled, then you take it will be like each cluster you take like a subset from
Okay,
each
let me
group.
just give you some scenario. So Florence, I pardon me, are you married?
Yes, please.
Okay, so how many do you have children?
One.
How many? One, right?
One. Yes.
Okay. And so let's assume that this is your family, right?
Okay.
So now we want to do a research about let's say, the number of times that you read your Bible. And
Okay.
this time round, we are selecting family members in that locality. So randomly, we selected this cluster, this cluster. Let's assume that your family is the cluster. So we said that we are going by a single state cluster sample. So when we select your family, it means that all your family members are part. That means you, your son, and your husband. Do you agree with me?
Okay. Yes, please.
Okay, now we say that this time around we want to go further. We are going to do another research, but this time around we are going to go by two-state cluster sample. So for this two-state cluster sample, we then selected your family, but because it's two states, we are not going to take each unit. We are not going to include you, your husband, and wife.
Okay.
This time around, we are going to randomly select one person in your family. Do you get it? So randomly, let's assume we selected you.
Okay.
Okay. So now we are going to ask our questions from you. Then we ask you, how many times do you read your Bible? Say, answer me.
Well, at least once a day.
Okay, at least once a day. And so that is what we call by the two-state cluster sample. I hope that is clear.
Okay. Okay. Thank you.
So you can mute yourself. And then I call Belinda Mensah.
Please, thank you very much. I have understood whatever you are saying, but my concern is
why bet? If you've understood it, why bet? Okay, talk. Okay,
I've understood a certain point. Let me say it that way. The part I don't understand is after forming the clusters, Are you going to number them in order for it to be randomized? Like after 40 classes, Asante region, this, are you going to? How am I going to select?
Belinda, your line is not stable.
Oh, my line is not stable, so you can't hear me say.
It keeps dropping. When you start, it gets to a point, it drops. So you start all over again. Let's see.
Okay, so you can't hear me.
Yeah, now I can hear you.
I wanted to find out that after forming the clusters, maybe Ashanti region, Eastern region, run a half region. How am I going to randomize them or select them? Am I going to number them as we did in the simple random
No, that's why I said that.
before?
Exactly. That's why I mentioned that at any point in time, you end up applying the simple random sampling because it is based on randomness.
Okay.
Randomness means that it is happening by chance. You don't just predefine that because your family members are in Ashanti region, so you go and choose Ashanti. No. If you do that, you are introducing some biasness.
Okay, thank you.
Yeah. Please, Halima, please hurry up. Halima, talk to me.
Okay, so thank you. My question is with the two-stage cluster sampling. So with the scenario of Ghana, when after grouping them into clusters, grouping the regions into clusters, and now with the two-stage cluster sampling, can you say maybe when I go to Kumasi, I'll divide, maybe I'll sample them into maybe sex, females and males. Then I'll use that for my research.
You said that when you sample Kumasi.
Yes, please. With the scenario you used concerning the country, the whole Ghana. Now you said with the cluster sampling, you sample them into regions. You sample them into regions. So I want to understand two-stage cluster sampling. Maybe you take a chance. Can you sample them into? I want to understand the two-stage cluster sampling. So can you say maybe taking Ashanti region, I'm going to maybe cluster them into male and female.
Male and female for what? Is it this thing that you are saying? You should know the specific let's say objective that you are dealing with. You see, male and female, you see, that's why I use household. You want to get information from household. Do you get it? But the example that you are citing is I'm finding it difficult to get it very well. But if you mentioned that probably you selected Ashanti region, and now from the Ashanti region, you see we have let's say, how do I put it? This districts, yeah, you have districts, right?
Yeah.
Now you can see that, oh, okay. Now you come in Ashanti region, you are going to select some districts to represent that. And so now that you've come and now you are using the districts, now the districts are now the two states.
Okay.
I don't know if I'm making sense.
Okay. Okay. All right. Thank you very much.
No. Okay. Sarah Boachi, please. This is your last one. The next time, if you give me feedback, I will take you out. Now, I think I have just two hands. There was one person I asked to come back again. I don't recall the name, but if the person is part of these two, that's fine. So after these two, I'll move on to the next. Okay. Now let's move on to the next one. Elizabeth Danswa or what?
Yes,
Elizabeth.
please. So please, it's Danswa.
Okay, talk to me.
So please, so I wanted to know the difference between the cluster sampling and the stratified sampling. Does it mean that the cluster sampling is used for a large geographical area? Because I got a little bit confused with that.
Yeah, that's one point. But another point that I can put out is you see that for the stratified sampling, you can see that they are different. If you look at this group, if you compare between them, you see that there are some differences between them. But for the cluster, if you compare them, they are the same. For example, the regions, they are all regions. If you compare region one, region two, but for the stratified, you can see that when I choose the midwives from Y, the midwives from, let's say, um, Ashanti region, it was the reason why I used to form the groups was based on ethnicity. So it is perceived that those in Y are having different ethnic characteristics. Those in Ashanti are having another characteristics. I think basically that's what I can give for now. But notwithstanding that, I think you can also research and get some additional thing. I hope I've
Okay.
made sense.
Yes, please. Thank you. So I have said, please, so you can use the stratified sampling for wide geographical area also.
No, that one. If I'm a researcher and I'm marking that, I'll mark you down.
Okay.
But you can, okay, we'll get there. I think there's another sample technique there which you can combine with, and then you appreciate it.
Okay, please. Thank you.
Okay, so the last person, Mensa.
Sir, please, that was the same question I wanted to ask. The difference between stratified and cluster sampling.
So let's move on. So you can lower your hand and let's move on to what we call the systematic sampling technique. So for the systematic sampling technique, you are going to select every key item. Every key item. You are going to select every key item. So if you have, I'm going to give a scenario for systematic sampling technique. The basic example, the definition is you select every key item. You are going to select every key item at a regular interval in the population. At that point, for example, when I come to your facility and let's say I want to select some folders in the shelf. Let's say there are 40 or 20 folders in the shelf. I want to select 5 of them. So now I can say that I'm going by systematic sampling. The reason why I'm going by systematic sampling is if I don't go by that and I go by simple random sampling straightforward, it is possible that I can select only the first 5 folders in the shelf. And these first 5 folders in the shelf may be they visited the hospital recently. And so that may not be a true reflection of all the folders in the shelf. So it's better I go by the systematic sampling where I can select let's say every 4th item, every 5th item, whatever. Another example is, you see, when you go to these so-called residential areas, the houses or the households, they may be in a line form. This is house 1, house 2, house number 3, house number 4, number 5, number 6, 7, so on and so forth. And so if it's better you go by systematic sampling so that you can select each house so that it can be a true reflection of these individual households in a line. And how do you do that? You go by what we call systematic sampling by selecting every key item. And this key is just a position. It's just a position. So for a queue like this, let's assume you want to select every 3rd person. That means that you select this guy randomly. Don't forget that from 1, 2, 3, you randomly select one. Then you can 1, 2, 3, randomly select one. But how do you know this key? Someone may ask, say, how do I get the key? The position that I'm going to sample. The key is always equal to capital N over small n. I hope you remember what capital N stands for.
Population.
Good. Good. So the capital N stands for the population and the small n stands for the sample.
Size.
Okay, sample size. And that is the calculation here. Okay, so now let's give ourselves an example. Let's assume that I have 20 individuals in a queue, or let's say 20 houses in a queue, that we have to select 5 from them. Okay, so we will need to calculate our K. We will need to calculate our K. And how do we calculate our K? It's going to be the population size, which is 20, divided by the sample size, and that will give us 4. And so that implies that our K is 4. So if I have house 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. Okay, so that means that is 1, 2. So that this is number 1, number 2, 3, 4, 5, so on and so forth. So now that I know that my K is 4, it means that I'm going to select every 4th house or every 4th person. Every 4th house or every 4th person. That is what I'm going to select. So your starting point, you can always start from 1 up to K. That can be your starting point. So that implies that we can start from 1 up to what? 4. That means that you can start from 1 up to 4. So the 1 up to 4, you don't just start from 1 up to 4. Probably your family's house is number 3. So you just say, oh, I'm going to start from number 3. No. You don't do that. So you can number, you apply your simple random sampling. 1, 2, 3, 4. Then you randomly select your starting point. The moment you get your starting point, then you select every 4th item, So for my example, you see that I have N1. The N1 here stands for the first selection. The first selection, the starting point. And then N2 stands for the second starting point. Okay, N3 stands for, the second selection. N2 stands for the second selection. N3 stands for the third selection. So if you look at this one, we can start from 1 to 4. And so that is what I'm doing here. Okay, so 1, 2, 3, 4. That is 1 up to K. I hope you can all see that. 1 up to K. I hope you guys can see it. So randomly, I selected 3 as my starting point. It doesn't mean that if you also go there, you two are going to select 3. It can change. It doesn't matter. Okay. So randomly, I selected 3. So 3 plus 4 give me 7. So it means I'm going to select the 7th person. Or you can move in steps. So 1, 2, 3, 4. Then you select this guy. Because we are selecting every 4th item. So you've selected. So now we have to count 4 and select 1, 2, 3, 4. Then we select this guy. Then we count 4. 1, 2, 3, 4. We select this guy. We count another 4. 1, 2, 3, 4. Then we say, you see, at the end of the day, you selected how many individuals? The 5 that we want. Remember that N was equal to 5, which means that our sample should contain 5 individuals. And then we have these 5 individuals. And so this is what we call the systematic sampling technique. I hope that is clear. And so,
no, sir.
Sir, it's not clear.
It's not clear.
So please,
I'm confused with the
if you have any
calculation.
question, if you have any question, please, you raise up your hand. I think I have to stop. If you have any question, raise up your hand. So when I give you the opportunity to ask your question, please you ask the question. This is just a simple calculation. There is not any rigorous calculation. You are just dividing your population size by your sample size. And per this example, we are saying that the population is what, 20. Can't you see that? The population is 20, n is equal to 20, and then the sample size is 5. So if you divide 20 by 5, you get 4. So that implies that k is equal to 4. So it means that we are going to select every fourth item or every fourth person. And so let's assume that 1, 2, 3, 4, these are folders. Let's assume these are folders in the shelf. Okay, the last person here is 20. So these are folders in the shelf. And then now you've calculated that you are going to select every fourth folder. Every fourth folder. So if you are selecting every fourth folder, that means that when the moment you select one, the next 4 you are going to select, the next 4 you are going to select, the next fourth folder, the next fourth folder you are going to select. Okay, and I'm saying that for it not to be biased, you need to start from 1 up to k. So this 1 up to k, we know our k to be 4. So it means that we can start from 1 to 4. 1 to 4. You can start from any point. But you don't just go and start from number 1 all because you know that person's folder. Probably the person comes there, he or she gives you money, so you are going to pay that his folder and use it. No, you don't do that. If you do that, you are introducing some biasness. So what you do is you randomly select your starting point. Randomly. And this example, I have randomly selected number 3. If these calculations will confuse you, just forget about it for now. So I have randomly selected number 3. So that means that number 3 is the folder that I'm going to select. And now that I know my k to be 4, it means that I'm selecting every fourth folder. So now I've selected number 3 as my starting point. So you have to count. 1, 2, 3, 4. Then you just remove this folder from it. Then you count again. 1, 2, 3, 4. Do you get it? Then you take your folder. 1, 2, 3, 4. Then you take your folder. 1, 2, 3, 4. You take your folder. And now you check in your hand, you see you have 5 folders. So you have your sample. And that's what we call by systematic sampling. And in real life, you can also apply this on the household thing that I cited. If you go to the residential area where you have houses in a queue, you can apply, after you've calculated all these things, you can apply the systematic sampling technique. Okay. So now you can raise up your hand and then ask your question, please. Please, if you have a question, ask. Belinda Mensa. Please, if you have a question, you raise up your hand.
Please, the starting point, that is the third person that you choose. That means you are not going to drop that folder. I mean, you not select that folder, but you use it to calculate the fourth person so that you select their folder. Is that what you mean?
I think if I get you right, if I select 3 the starting point, right? So the moment you select 3, you are now 3 is part. Because you see, you started from 1, 2, 3, 4. From there, you selected this guy.
Okay.
So 3 is part of the sample. You don't just leave it. Okay. Then you continue to count your 4 and do your selection. Okay. So you get your sample size.
Okay. Thank you.
Okay. Abena Bodo. Abena.
Sir, please, I want to ask that. So does that mean before the selection, you can only do the selection when you've done your calculation and found your K, right?
Exactly.
Okay.
And you can also see that this one, it depends on the population size. So if you don't know your population size, it will be difficult for you to use these sampling techniques because you need to calculate your K.
Okay, thank you.
Josephine Inkum.
Please, good morning.
Good morning.
Hello. Sir, please, what does the K stand for?
That's why I cited that the K is just a position. The K is telling you the position at which you are going to select in a regular interval for this type of method. Okay. Please, if I've answered, you put your hand down, then I call the next person. Okay, Josephine, I've answered, you can. The next person is Juliet and Kara. Juliet, please talk to me.
Yes, sir. Please, about the calculations. It said our N1 is the starting point, which is the 3. Then the N2 is the N1 plus the K, which is the 4. So we got 7. Now the N3 is equal to N2 plus the constant, which is the K. Then we got 11. So that 11 stands for what?
I'm saying that these N1s are the individual that I selected. You see, you can predetermine the numbers that you are going to select. Do you get it? You can predetermine. So probably before you go to the shelf, you have calculated the numbers or the position that you are going to select in the shelf. So after you've calculated this, you just move in there. 1, 2, 3, I take 4, 5, 6, 7, I take it. 8, 9, 10, 11, you take that one, so on and so forth. But if you think that this thing will confuse you or whatever, now you've calculated your K. Then you move in step 4. Every 4, you pick every 4. You pick. And that's what I'm doing here. You see that this K, this is the K, and that is the K. You get it? And this N3, as I said, these are the individuals that I selected. So N2 means that I'm going to select the 7th folder. N3 means that I'm going to select what? The 11th folder. So if I want N4, N4 is going to be
the 15th person.
It's going to be 11 plus 4, and that will give me 15. So if I want N5, it's going to be what? 15 plus 4, and that will give me 19. And I have my sample.
Thank you very much.
Benedicta.
Sir, please, you just answered my question. Thank you.
Rosemary.
Okay, sir. Please, I wanted to know with the first random selection, that is the N1. Does it necessarily have to be the number 3, or you can select
No. That's why I said random. That's why I said that if you do it, it doesn't necessarily mean that you are going to get number 3. Random. If you select number 1, then it means you move on. You move on. If you select number 2, so it's random. Okay? Based on randomness. Okay. Now let's move on. Once I don't have any question, I think we can move on, okay? Okay, Josephine Kuma, talk.
Sir, please, the network was worrying me, so can you kindly explain it for me again?
No. The network can't be excuse for you always. My dear. The network can be a skill for you guys always. Okay. Because if I move and then we get network issue, it's a problem. Anyway, I'm going to go over. I'm going to go over, but what I would say is, please, if you have a network issue, try to, solve it, because it's as I think next week or two you start with some calculations. So if you have network issue, it may be a challenge. Okay, so please, I'm begging you, try to solve that. Okay, I'm begging you, please try and solve that. Okay. I know it's this one, you don't have control over it, but do your best to solve that issue. Okay. Now, the lady who said, Josephine, please come again. You said that network issue, so I should do what?
To go over again for me, please.
I should go over what I've taught from sampling techniques to now. So what do you want me to go over?
Yes, this part.
What? Please speak a bit louder.
It is just this part, the calculation part.
How I got the 4, or which one?
Yes, please.
Okay, so the 4, I got it from this. You see, the formula is giving us the population size divided by the sample size n. And the scenario is we have a population size of 20, and then we want the sample size of 5. So we divided 20 by 5, and then we had 4. Have I answered you?
Yes, sir. Thank you.
Okay. Please, any question? Okay. There's no question. I can see no hand up. Let's continue. Okay, so now let's go by, the next method is very simple. And I think this is what one of you were trying to cite some example. Okay, so multi-stage sampling. So multi-stage sampling, whenever you use, let's say, one or more of these techniques, let me say more than one of these techniques. When you use more than one of these techniques, then you are applying what we call multi-stage sampling technique. Okay, so a sister was citing that, okay, if I want to do a research in Ghana, I can do cluster and do stratify, and I apply my simple random. Then I said that she should wait. I'll give her a scenario or a type of sampling technique that suits her narration. And so you will see that when you want to do a research, let's say in Ghana, you can go by, let's say, the multi-stage sampling technique. Okay. This time around, you start by the cluster. You use regions as clusters. Okay. Let's assume there is a research on, let's say, interest in malaria vaccine. The interest in malaria vaccines. So for this research, you can go by the clusters. You start by the cluster sample in Ghana. So you randomly select a region where you are going to interview them on the uptake of malaria vaccine. So after your selection, let's assume you selected Ashanti region. So now that you've selected Ashanti region, then you say that, okay, now I can go and use stratify sampling. I'm going to group, because Ashanti region, I have different ethnic groups here. I can use stratified sampling. I can group the individuals in Ashanti region into stratum based on ethnicity. So I put all the accounts in one, all these airways, whoever, in one, so on and so forth. Then you can now apply your simple random sample inside. So you see that if I apply more than one of these techniques, so what I'm doing here is what we call the multi-stage sampling techniques. Multi-stage sampling techniques. So whenever you apply more than one of these techniques, and so there's a sketch here from the population, you can start by the cluster, okay? Then you form stratum, okay? Okay, you form stratum in there, then you do your selections. So that is what we mean by the multi-stage cluster sampling. Now this one, I don't think there will be much question on this. The multi-stage cluster sampling. Okay. I hope that is clear. And it doesn't necessarily mean that you can, for example, the example that I cited, you can start by cluster where you select Ashanti region. Then you form another cluster again using the districts. Then you do another selection. Then you go in the districts. Then you can now apply your stratified sampling. Then you do your selection. So it depends on you, the researcher. The moment you use more than one of these techniques, what you are doing is a cluster sampling. Oh, sorry. Multi-stage sampling techniques, multi-stage sampling. Any question on this? Then I move on to the non-probability sampling techniques. Okay, I think, okay, I've seen someone. Elizabeth, please ask your question. Permit you to unmute yourself. Unmute yourself.
Okay. So please, can you go over the multi-stage sampling again? I was a little bit confused.
For this one, I'll not go over. I'll ask some of your mates to go over. Can someone help her out?
Yes, sir.
So please help your sister.
Please, you said for the multi.
No, this time around, you know it. You know it. Don't say you said. You know it.
Okay.
So explain. You know it.
The multi-stage sample, using one or more of the samples, maybe the cluster, the simple, using using the cluster or the simple, both is mixed or it's multi. Yes.
Thank you. So what she said is right. Whenever you use more than one of these techniques, that is what we refer to as multi-stage sampling. So you can start by, let's say you are working in Ghana, you can start by cluster, and then you can also move on. After you've selected your cluster, you can form another cluster within the cluster by, let's say, districts. Then you pick your district. After that, you can now divide the districts into, let's say, communities based on stratified sampling, and then you can now select. You can do these things so many times, so it depends. Okay. So the moment you apply more than one of these, you are doing multi-stage. Sarah, talk to me.
Okay, so please, can I give an example of the multi-stage where maybe randomly I select 10 states, and after selecting the 10 states, I also select 5 districts from each of the states, and
You select
afterwards I said I'm giving an example. Maybe
Okay.
randomly I select 10 states, and
10
in the 10 states, like
states.
America, yeah,
States. Oh, okay.
yes, sir.
Me, I'm not
And
privy to these states, so that's why. Okay,
okay.
continue.
And randomly I select 5 districts from each chosen state, as in the 10 states, yeah. And after I also select 4 neighborhoods from each district. And finally,
My dear,
I select
you
households.
just end there. The moment you are
Okay.
doing this thing more than once, you become multi-state.
Okay. Thank you, sir. Thank you.
Okay. Any other? Okay, there's no hand. Let me just pause and then. Okay, so now let's move on to these ones. I'll finish in the next 5 minutes. I'll finish with the non-probability sample because it's even biased. So the explanation itself is biased. Okay, so these things are not exhaustive. The probability sampling technique. You see that I said that these things are biased. So anybody can come up with his or her own, but you just need to justify it. And then we assess it to critique, and then if it's accepted, you are good to go. Okay. So it depends on you, the researcher, because it's biased. These things are based on biasness. Something influences how you do your selection. Okay, so for the first one is what we call convenience sampling. So for the convenience sampling, you sample based on availability, how these individuals are available to you. Do you get it? So that one will influence how you do your selection. In most cases, it is used for a pilot survey, pilot work. When you want to pilot, you go there and sample how based on how availability they are. Okay, so for example, I want to do a research in, let's say, for midwives in Ghana. And as long as I teach midwives, I'm saying, okay, these people are available. So I'm going to use convenience sampling to select midwives and ask my questions from them. At the end of the day, what I've done, I've sampled, but I've used convenience sampling. I sample based on my own convenience. And that is what we refer to as convenience sampling technique. The next one is what we call purposive sampling technique. This one, I'm going to do everything, then I take questions after that. Okay. So the next one is what we call purposive sampling technique. Purposive sampling technique. So the purposive sampling technique, you sample based on the purpose of your research. So the purpose of your research will influence how you do your selection. The purpose of your research is going to influence how you do your selection. Okay, so for example, with regards to the midwife that I'm researching on, but this time around, the purpose is to know the impact of biostatistics on pregnant women. So you see that here, I'm going to select only pregnant women for this research, but they are all midwives. Why am I selecting only pregnant women? Because the purpose of my research is geared towards pregnant midwives. So you see that I've selected based on the purpose. So the purpose has influenced how I do my research. The purpose has influenced how I do my research. So here I can say that what I'm doing here is what we call purposive sampling technique. The purpose of the research has influenced how I do the selection. Okay, the purpose of the research has influenced how I do the selection. Okay. Now the next one is what we call quota sampling techniques. So for the quota sampling technique, that one too is very simple. Here, the researcher will only select based on certain characteristics in the population. So that characteristics will influence how he does his selection. For example, if we come to the class right now, I know that about 99% of the class are females. But right now, I'm the only male, possibly the only male in the class right now. So now the researcher will say that since I have a lot of females in the class, I'm going to let this characteristics influence how I do the selection. We are all in the class, but this time, because of the proportion that I have a lot of female, I'm going to say that, okay, this time around, I want my sample to contain about 90% of the sample should contain females and just 10% male. Or let's say majority is coming from the females and minority will come from the male. So you see that here, because of that characteristics in the population, I've predefined that I want this group or this characteristic to contribute its quota to the sample. So that characteristic is contributing its quota, and the other characteristics is also contributing its quota. So if you go by this, that is what we call quota sampling techniques. So you let the characteristic in there influence your selection. Do you get it? So for example, with regards to your class, I can say that, oh, okay, maybe I can get a lot of you guys coming from Kumasi. So if that's the case, then I'm going to select most of these midwives who are in Kumasi than the rest. So you see that that characteristic has influenced how I do the selection. And that's what we call by quota sampling technique. Quota sampling technique. Now, the last for the day is what we call referral or snowball. So for the referral or snowball, what you have to do is you first have to identify one person or one element from the population, and he or she will recommend you to the other element or individual in the population. So you get your sample size. So for example, in the class, there's rumor that why do I keep changing this thing? Okay, let me go back. In the class, there's rumor that there's a lady in the class whom I'm dating. There's rumor. Let's say the name of that lady is Gifty. Okay, so now this rumor is going up. Rumor BOFA, Dr. BOFA is dating Gifty here and there. So what I'll do is I'll first need to contact the class rep and ask the class rep, hey, what's this thing that you are saying about me? Then she say, oh, no. It wasn't me. It was this lady. Then she refer me to another person, and I go there. That person refer me to until I get my sample size. Okay, and these are the things that you guys do for your contact tracing. Remember COVID-19, the contact tracing. You remember that when we will first need to contact you, the person having the COVID-19, then we ask you, where did you go? So you will refer us to the potential individual that you contacted. Then you go there, then they will, till we get to the last person. And they do the same thing for the security sector when they are doing their investigations. They need to just identify one suspect, they move on till they get to the last person. Okay. In most cases, this one, it is used for very, very sensitive research. Example, if you are doing a qualitative research on, let's say, HIV patient, if in the university right now, if I'm to identify HIV patient, it will be difficult. But if I do my best to identify one person and I even end up motivating that person, and I assure the person that it's purposely for research, the person is likely to recommend me to another individual whom I can get information from. Okay, and so when you go by these, that is what we refer to as the referral or snowball sampling techniques. Okay, so for the formula for determining the sample size, I'll talk about it later. You can skip these ones. I've updated it, and this is a table that you can use to calculate your sample size without doing any calculation. You can read it and then, but you move on. I'll skip all these things and then we will do the manual calculation, which probably God willing we will do that next week. So next week, please make your calculators ready. We will do some basic calculations, and then I'm not going to do it. I'll ask you to do it over there. So get yourself calculators If you don't get yourself calculators, and then you ask questions, me, I'll mind, because if you ask the question, I'll ask you to compute it there. If you said, why did you get this? And I'll ask you, okay, point this, that, and then let's give her the answer. So please, I'm begging you, I'm pleading with you, get yourself calculators, okay? Okay, so let's take questions. After that, I end the class. I approximately have about 50 minutes. So let's take the questions and then I'll end the class. If you have any question with regards to what I explained, please ask the question. Please, if you have any question, you talk to me. Okay. I'm not getting any questions. So can I leave the class right now? Let me permit you to unmute yourself. Okay, Sarah, watch it. Unmute yourself and talk.
Hello, sir. Hello.
Yes.
Hello, sir. Please, can I say convenient sampling is informal and unconstrained? That is first come, first serve. Can I say that, please?
Oh yeah, it depends. That's what I'm saying. That it's based on your own convenience. So if that is convenient to you, why not? It depends on you.
Okay. Okay, thank you. Okay. That means, sir, please, it's highly biased. Can I also say that?
Oh yeah. All these are bias. All these are bias.
Okay. Okay, sir. Please, thank you.
Okay, so if I don't have any question, I think I can leave, right?
Yes, sir.
Okay, so please take off yourself. Then God be with us all. Okay, so God willing, we meet next week. Bye-bye.
Bye.
Bye. Thank you.
Bye.
Bye.
Bye. Hello, Busia, for a coin year, dear. Yamin Kyle. Hello.
And call you to better than yes, can we move on?
See you down Kabiku, but I said Dawson.
Goodness,
We are aware some more recorded, you know.
So we know I said two questions. It's like I saw in your butcher. I won't take you one after the other.
I didn't call you.
I was already.
because
Don't worry. We are going to test A in biostatistics. Don't worry.
Amen.
We'll get it. The course that you think is very difficult, and at the end you even score that course more than. So you don't worry.
Let me respond. Oh, but I still understand the question and they're able to answer.
One after the
No,
other.
we will answer them all. God's grace.
Yo, amen. Bye-bye.
I'm also this slide and I'm going to read it.
Which one is our next subject? Our next subject.
Chemistry again.
Biochemistry.
I'm sure. That's the same. Yeah, the link in the bathroom of mine. About yeah, into me and call you know. Class. Yeah. Connect pen. What oh the about to mama one near to me I join it. Yeah, that's a so far what boy. All the 2 classes. And yes, I can music coming to me. To virtual entrepreneur. You do up and now they are about to mama. Why? That's it.
Chill. What time is our next? What time is our next class?
In our second semester, a pilot degree in Terradina and Babuanesa. Normal labor no one in the can so.
When I make a sister. Hey, she's a labor.
Make sure calculations made sister need. What's your second now with formulas, baby, where the media, but where the media, but
study group, I'm join you. The more study group, I'm maybe I join it.
I'm